My name is Kaiwei Yang. I'm studying in chemical engineering department. My advisor is Yonghuan Li professor. Here is the report of the chemical engineering field practice research about some patents. My research, I'm doing the research about the next generation batteries. For example, lithium-sulfur battery, sodium-ion battery, or potassium-ion batteries. Here I did an investigation about the patents of the binders for the lithium-sulfur batteries. The binder is used for prepare the cathode or the anode materials in the batteries. But in the lithium-sulfur battery, the anode is a pure lithium metal, so the binder is only for the sulfur cathode. Lithium-sulfur battery has some very advanced advantage figures. It has very high theoretical capacity. It's about 1,600 milliampere per gram, and the cost is very low because of the sulfur. And based on the reaction mechanism, the sulfur transferred to lithium sulfide when it is discharged. After charged, the lithium sulfide recovers to the sulfur. But during the cycling, there are some soluble lithium polysulfides, and it can dissolve in the electrolyte solvent. So the dissolution and the shuttling effect of those lithium polysulfides caused the loss of the sulfur active materials in the cathode side, and the low conductivity of the sulfur brings the inferior rate performance of the lithium-sulfur batteries. Here is an example. This paper reported cellulose and the glucose composite binder to inhibit the shuttling effect, because the glucose can combine with the polysulfide very tightly compared with the conventional CMC binder. And also the glucose and the cellulose composite binder form a very porous network on the cathode side, so it is good for the lithium ion transport, as you can see the scheme figure in figure F. And also the composite binder has very high adhesive property on the current collector, so the structure of the cathode can be stable during the cycling. About the lithium-sulfur batteries and the binder application, most recent patents are from LG or LG Chem or LG Energy Solution Company. And therefore, actually, LG Chem provides a prototype of the flight based on lithium-sulfur battery 2 years ago, and it really inspired the researchers of the companies to develop lithium-sulfur batteries. But except the polysulfides inhibition effect, as you can see from the figure from the first patent. Except that function, the fabrication process is also very important for the binder, because in the second patent you can see functional binder can keep the electrode and the electrolyte contact better, so the performance is improved. So therefore the functional binder should be developed to maintain the polysulfides, and also the fabrication process and the fabrication method is very important as reflected by the patents. Then so the function of binder should be carefully considered to make the practical lithium sulfur batteries.